build something that you're really interested in that seems useful to you. Like even if it seems very difficult, if it seems over ambitious, there are tools out there today that didn't exist a couple years ago, even 6 months ago, that will make your life way easier.
Well, David, for people who don't know what you do and what your work is, what are you really trying to achieve through your work?
Yeah, so I'm one of the co-founders of OpenPipe. OpenPipe is a platform that helps small models win. That's how we like to describe ourselves. So there are a lot of extremely strong and getting stronger closed source models that are useful for a variety of tasks. They're extremely general purpose. OpenPipe is a way to to easily make small models better than those large models at your particular task. So if you're interested in saving money, reducing latency, or improving quality, that's usually what takes you to OpenPipe. Now, how we do that is actually kind of split down two paths. One is supervised fine tuning, which is a way, given a data set of like correct outputs, it's a way to teach the model to emulate those correct outputs. And the other way that we do it, which we're focusing more on these days, is reinforcement learning. And that's a way to adjust the model's weights over time to sort of shift its behavior more toward a desirable set of token generations. So you kind of let the model learn from its own experience. Um, and the end output of both of these techniques is an open source fine-tuned model that outperforms any closed source model at your particular task.
Why do you think these methods are so important in developing models, and why should a lot of people take an interest in this?
Yeah, I think there are a few different reasons that you might care. I think the most important one for most people is quality. So if you are not one of the big labs, then you don't have full control over how models like O3 or Sonnet 4 were trained. If you happen to have a task that's extremely similar to what they were trained for in the first place, then they'll probably perform extremely well for you. If you happen to have a task that's quite different from what these models, like from what they saw during the training phase, then you are likely to run into a lot of bugs. And most people have tasks that are at least somewhat different from what the big labs were focused on, reinforcement learning. Um, so that's kind of like the biggest reason that you might want to adjust these weights for yourself is just to get better quality, to increase the reliability of your models. There are secondary reasons as well. Like I said before, cost does decrease substantially when you switch from a model like O3 or O4 Mini to a 7B or 14B Quen model, for instance. And latency can also decrease immensely, especially if you're hosting one of these models on like, a dedicated deployment on an H100 or Grok or wherever. You have a lot of freedom. So that's those are like the, I guess, performance reasons that you would do it. And finally, if you want your business to be independent of OpenAI's and Anthropic's decisions, and like you don't want to worry about being, for instance, Windsurf, who got their models turned off because OpenAI thought that they were a threat. Um, or maybe it was actually Anthropic. It was one of those two. I think it was Anthropic turned off Claude for Windsurf.
Oh,
And if
wow.
you don't want to be like one of these startups that gets eaten alive by the huge companies, sucking everything in to their whirlpool of economic concentration, then having your own models and not being reliant on a central provider is important.
I think I heard exactly that on the discussion of like Windsurf getting acquired. What ended up happening was OpenAI essentially gutted the entire company. So you have all these people that worked so hard on Windsurf, but then didn't really carry on to be a part of the company. And something I saw this whole controversy because like they got rug pulled essentially. That was like the whole message, right? Like they weren't able to have their shares. I forgot what the term was, divested or invested.
Probably vest.
Yeah, they couldn't get their shares vested. So as easily as you can create wealth from this AI generation, you can also get rug pulled, which was kind of the essential message. But something that came up in my research that I'd like for you to clarify on is like when we talk about pricing with AI models, can you kind of walk me through like what kind of goes into pricing these days? Is it the API calls? Is it the expensive chips itself? What is exactly contributing to the cost of training an LLM?
Yeah, so the cost of training has decreased substantially in the last few years. It used to be hundreds of dollars, even for a pretty basic data set. Now it's like $10 to $20 usually, sometimes up to 50, but it's relatively cheap. I think there are a couple reasons that the cost has decreased, which I suppose in a way answers why the cost was so high. One is that we're now training LoRa, so we're doing very seldomly full fine tuning, which is adjusting all the way to the model. And instead, we're training a very narrow uh, set of weights called this. It's kind of like this extra set of weights, LoRa, that you put on top. Um, and so because you're training much faster, or because you're training, so much fewer weights, you're training much faster, and as a consequence, you're using an H100 for less time. So both for uh, both for training and for inference, it's usually time on an H100 that's contributing to the costs. Now, I do expect training to get even cheaper and inference in the short term to get quite a bit cheaper because the cost of an H100 is dropping rapidly as people transition onto H200s. Um, and and uh, and so yeah, things will get cheaper soon. I believe.
And for clarification, most people are buying their own hardware because I heard something. I saw people talk about like cloud computing as well. Like people will just pay like a server to essentially compute for them. But is it in your experience that a lot of people just buy the chip flat out?
I would say a very small minority of people actually buy the hardware. I think if you're a very large business, you might buy your own H200s or H100s. That's quite uncommon. Even some of the very large businesses that we work with primarily use services like AWS or RunPod to what or these other hyperscalers like Azure to rent GPUs because it just doesn't make sense unless you're concerned about privacy. That's really the only, or if you're trying to train your own foundation model, those are really the only reasons that you'd want your own cluster of these GPUs. Now, when you get into the government or when you get into extremely sensitive military contractors or whatever, then they sometimes, for data privacy reasons, will actually buy their own hardware, run everything on their own hardware. But I don't think it makes sense economically. I think it's more a question of security.
Mm, gotcha. But either way, OpenPipe was able to do what they do the best.
Yes, yes. We can run either on private hardware or on shared deployments.
Gotcha. Okay. Well, aside from the chips itself, what else do people really need in order to get like started with reinforced learning? Is it something that's as intimidating as people say it is? Like it seems like you need like this big code base and you need a bunch of data. Is it as difficult as people might see it as or
No, no,
intimidating?
no. Reinforcement learning. Well, okay, let's go back and speak historically for a moment. Previous to LLMs, like I think in most domains, reinforcement learning is still complicated enough that you probably do want a PhD or a master's, or have spent like, a year or two before you do something in production, have spent a significant amount of time reading up on papers and like looking at the latest algorithms that have been released, and it's going to take some time to get started. And the reason that it'll take so long to get started in these other domains, not LLMs, is that there just aren't enough people out there for it to be worth their while. The demand isn't there for the tools to make these other models, like non-LLM ones, easy to train. Because like if only 50 people in the world are doing it, it's unlikely one of those 50 people is going to make this awesome GitHub repo that simplifies the process for you. Now, LLMs are different from a lot of other models because they're so generalizable. And that means that the market for making them better is huge. There are hundreds and probably at least tens of thousands, maybe hundreds of thousands of developers out there who want to improve their models. And so there's huge demand. So we have our own reinforcement learning library. It's called Agent Reinforcement Trainer, and it's on GitHub. It's all open source. It's super simple to use. We're not the only one. There are some other really good projects out there. Verifiers is another good example from Prime Intellect. And you can also look at Unsloth. They've got a GRPO trainer implementation. Ours, at least in our view, of course, we're biased. We think it's the easiest to use. We think it's the most robust. Um, and it allows for multi-turn agent training. I don't want to get too into the weeds. You should check out art though. Your listeners should check out art. But yeah, to answer your question, it's quite simple. So what you need is any app that uses an LLM. And you also need to like have some idea of what sorts of things your LLM will have to do. So we call these training scenarios. For instance, if you're like training a model that like searches emails, so there's a good blog post we can link to the video. If you're training like an email search agent, then you need to have a whole bunch of sample questions that you might ask to search through your database. And what these are used for is putting the model through its paces. So like forcing the model to do its task in a simulated environment, and then grading its behavior. If it succeeds at the task, then it gets a high grade. If it fails at the task, it gets a low grade. And shifting the model's weights to make the outputs which received a high grade more likely, and the outputs which received a low grade less likely.
What I found really cool about that blog post too, and I do recommend a lot of people listen to that or read about that, um, is the fact that you guys also implemented this strategy. I forgot what it was called, but essentially you asked the LLM to take all these emails and then you had it ask questions for it to answer, right? Can you go into like why you did that and why that was a part of the process?
Yeah, so like I said, one of the key components that you need here is a list of scenarios that the model might have to face in production. And in the case of the email inbox, so this is ART-E that we're talking about, which is a Qwen 2.5 14B model that was trained to outperform O3. O3, I think, found the correct answers to its questions 90% of the time, and ART-E found the correct answers 96% of the time. So that's a 60% reduction in poor performance. Um, I think that like in this case, we needed to make sure that the questions that we asked matched emails that were actually in our email database, our sample email database of Enron's downloaded emails. And the best way to do that was to actually start with the emails themselves that we wanted the LM to find, and then work backwards and say, okay, what sorts of questions could we ask that might be answered by these emails? And that's how we created our data set of scenarios. In most cases, it doesn't need, like if it's your own email inbox, for instance, that you're training on, then you probably don't need to go backwards. You can just like, you know what's in there already. And so you can start with just generating training scenarios. But in the case of Enron's email database, like there are hundreds of thousands of these, and we did not read through all of them. So we just asked an LLM to do that and tell us what sorts of questions the emails could answer.
Well, a part of that is also something that we talked about on our first conversation. It's like setting a realistic environment, right? It's
Yes.
about like being able to account for the kind of situations that the LM is going to run into.
Yeah.
What do you define? How do you know that you've accounted for all the situations? How do you know your environment is realistic enough? And what makes like a simple environment versus like a complex environment?
Yeah. So yeah, just to reaffirm what you said, these agents that are taught using reinforcement learning, they kind of like play how they practice. So if you set your LM up to learn in a fake environment and then you move it to another very different real environment that's more complex, it's quite possible it won't know what to do in that environment. So you want to train at the level of complexity or train as nearly as you can in the real environment where the agent will perform. What makes an environment more complex or less complex? That's really related to the task itself. Some tasks are very complex. Some tasks require a lot of external data sources. Some tasks are very simple. So, for instance, if you're training a model to play tic-tac-toe, for instance, um, that's an extremely simple task. All you need is a board. You need either an opponent controlled by another LM or a random opponent or whatever. But like the inputs to the agent's environment are limited because the task itself is very limited. In the case of ART-E, the environment is a little bit more complex because it has to deal with this huge database of emails in its training environment. And the reason it has to deal with this huge database of emails in its training environment is that it will have to do that when it's deployed in production and it's searching through your email inbox. So because the task that we are asking the LM to do is complex, the training environment needs to be equally complex. and kind of match the actual task. Now, in many cases, not in every case, but in many cases, you can actually use your real production environment uh, as the training environment, and that makes your life a lot easier and the development process a lot faster because you no longer need to create an environment in order to train the model. All you have to do at this point is come up with a bunch of realistic scenarios. You also asked, how do you like know that you've covered all your bases? The truth is you don't. Like you can't ever know with confidence, with complete confidence, I should say, that you have all of the pieces of like sort of the model's behavior that it will need uh, to to display or to perform well in production. But what you can do is, talk to your users. You can look at real usage of your app. You can see how people are using your model, and you can grab kind of the scenarios that you think are most common and some edge cases as well. The really nice thing about reinforcement learning is that it's an extremely extensible method for improving the model in the future as well. If it turns out that you run this model in production and it makes a mistake on a certain scenario, like a user asks a question you didn't anticipate. In the case of a prompted model, what you have to do, right, is go back to the prompt, figure out, okay, what can I change about the prompt to make sure this never happens? Um, you have to hope that you're not breaking any past use cases. Hopefully, you have some good evaluation framework set up, and it's representative of what you'll see in production. Um, in the case of reinforcement learning, if you've already set up that eval harness, you can just add the new scenario to your training set. So, like, I want the user to pretend, to do whatever your user just did that broke your agent in production. And then you can run your agent through that scenario a number of times, and it will actually become better at that particular scenario and others similar to it. So you can imagine after a few iterations of this, you deploy your first agent, it's good 90% of the time, but 10% of the time it messes up. You take a few of these edge cases where it messed up, you put that in the training set. Now it's, performing well 98% of the time, but it still messes up 2%. Okay, you take a few of those edge cases, you throw them in the training set. You can imagine, like, eventually you get to basically perfect because you keep on taking edge cases from production and moving them toward the simulated environment for the model to learn.
So when I learned about this topic, right, I found it interesting that you use the words it becomes perfect, right? From my understanding, it like the way it was explained to me, there's like these weights that are assigned to each of the scenarios, and then by running it multiple times, it becomes more and more favorable towards one. So in my head, it's not really a matter of perfection, but rather like the closest you can get to uh the real probability, I should say. Is it, am I thinking about that right, or is it a little
Hmm.
different?
What do you mean by the real probability?
So if I start off without no training on a model,
Hmm.
I have 50% chance I go to this Burger Shack versus 50% chance I go to Pete's Burger Shack,
Okay.
and we've never been to either Burger Shack, so we don't know how good their burgers are. So if I go to this Burger Shack and I like the burger, I can assign it a value of one, and
Hmm.
then I can shift the equation essentially to
Hmm.
favor more towards this Burger Shack. And you could probably kind of see where I'm going with this, but like, you have the introduction of the idea of the rate of learning and how much you want to shift that if you learn that you like this burger, even though you haven't been to this one. So by running that multiple times, you have this spectrum now where it's like you might favor this one because Jake's Burger Shack sometimes eats your burger, and you have like your reward of zero. So
Yes,
that's
yes,
kind of
that's
how
a
I
great way
pictured
of
it.
putting it. Yeah, so you're right. I think like maybe perfect is too strong a word. I think the asymptote, right, is 100%, 100% good behavior in production. You might never get to exactly 100%, and you wouldn't get that from a human or any other system, probably. But I think you can get very, very close to it. And there's no upper limit basically on how good your model can get because you can keep taking failing training scenarios from production and moving those into the simulation, let the model um, like try to handle those scenarios a number of times. And as long as it ever gets it right, right? Even if it only gets it right 10% of the time to start, you'll put a super high reward on the 10% of the time that it does get that scenario right, right? That it does go to the correct Burger Shack. and very soon the model will stop ever going to the incorrect one. Like even though yes, this is very probabilistic, the weights have been changed uh, such that it usually does the right thing, though it's never guaranteed.
Right. So when we talk about like giving the LM a proper reward,
Yeah.
um, from my research, there's a lot of different ways this has like evolved over the years and how this like technology of training in general has evolved. So could you kind of walk me through that? I've heard some terms like PPO, DPO, and GRPO. Like, what are all these different terms?
Yeah, great question. So there's been a lot of effort for decades, right, put into reinforcement learning. And LLMs only really came along as a significant part of the field, maybe maybe, back in 2016 when OpenAI was kicking the tires, some people were paying attention. But I think after the launch of ChatGPT, and GPT-3 before that, I suppose, that's when the field really started evolving more quickly. It got a lot more hype, which does impact AI researchers just like it impacts AI engineers. Maybe researchers are a little bit ahead of the curve, right? Engineers just have to deploy generally what they create, but there are hype cycles in both groups. Um, I think, yeah. So to start, like basically just giving a rundown of when you would use each technique. PPO can give independent rewards. Like you can independently send a single production run, like if your model's deployed in production and it did a bad job. You could send a single run of
What does PPO stand for again, by the way?
proximal policy optimization. That's right.
Okay.
And DPO, I believe, is direct policy optimization. Yeah,
I
direct
wouldn't.
preference optimization and group relative preference optimization. So these are different techniques for teaching the model to change its weights to perform better, and they're useful in different ways and have different advantages and disadvantages. So the primary advantage, or one of the most important advantages of PPO, which is the oldest technique of the three, um, is that you can provide independent agent runs. So, like on a single scenario, a single agent run, give it a single grade, and adjust the model's weights. And so this is really useful for learning from production. So if you're in production, right, your model's running. Sometimes the interface is with the user, sometimes it's writing to a system. You can't like rerun the model over and over again. You can't like create a simulation. So you have to deal with independent behavioral runs of a model, and hopefully you can assign some kind of score, like a thumbs up or a thumbs down from the user. So you can use PPO for that. DPO, on the other hand, requires, or it doesn't require, but it's a lot more useful if you have two outputs, one of them being good and the other being bad. So if you can, for instance, get your user to ask for a regeneration. So like, let's say you're in a chat interface, your user asks a question, your model gives an answer, and it doesn't like the user doesn't like the answer that your model gave. They can ask for a regeneration uh, of the answer, and if they accept that answer, that's a signal that the second output was better than the first. So now you can create a preference pair. So the first output will be considered bad. The second output will be considered good, and you can shift the model's weights away from the first output and toward the second output. So PPO, you're like doing this independently, right? It's just a single output. You're either given a high reward or low reward. DPO, you're doing this kind of in conjunction of two model outputs. You can do it independently too, but it's like one of the cool things about it is that you can use it with a couple model outputs, and you can actually push away from weights, or from a certain behavior. And then finally, GRPO, which is the most recent technique, I think pioneered by DeepSeek in 2024, um, or at least published then, is a technique for creating a bunch of outputs on a single input basically, and assigning different rewards to each. So instead of just two, you've got maybe like four or eight, and you can use the difference between the rewards on these models or on these model outputs to adjust the model's weights toward the outputs with high rewards and away from the outputs with lower rewards. And this is extremely useful for reinforcement learning, especially in a simulated environment, because it allows you to run the model, say, 100 times on the exact same scenario. Usually it's only like, 4 or 8, but you can go all the way up to 100 times, for instance. And if the model gets the like does the desired behavior 1 out of 100 times, you can push the weights. Um, you can push the weight significantly toward uh, showing that behavior again in the future, toward repeating it, and away from all of the behavior that it's shown in the past, like the other 99 out of 100 times. And so it makes it much, much easier and much more reliable to train your model to replicate behaviors that are initially uncommon.
Do all these methods involve a human? Because I heard some when I was researching and trying to understand these topics too, I kept seeing like reinforced learning with human feedback also. Is that involved in each of these methods? Does it only involve are humans only involved in some of these methods? Like, what is the role of a human here?
Yeah. So, like we were saying before, both PPO, DPO, and GRPO, they all require some kind of rewards on the model's output, right? The reward can come from a variety of sources. In the case of math, for instance, it's very easy to find your reward. You can just like if you give the model a math problem, right? Like 7 plus 10, you can say if the model's output is 17, then we give it a reward of 1. If it's anything besides 17, we give it a reward of 0, right? So that's a way to calculate a reward. But in some cases, it's a lot harder. And in some cases, you really do need a human or at least some kind of reward model trained on human feedback to calculate the rewards that you use that you assign to these model outputs and that these policy optimization algorithms use to change the model's weights. So yeah, I suppose the answer is human feedback can be used with PPO, DPO, or GRPO. In practice, I think it's more often used with PPO and DPO because it's much more expensive, right? GRPO is useful if you have a lot of model outputs that you're comparing to each other, and it would be pretty expensive to pay humans to like grade all of these. So usually that's automated. But sometimes in the case of PPO and DPO, you actually are getting real human feedback and using that.
Super cool. And I know there's a lot of popularity and talk around OpenPipe and how you guys released your own method of training a model. So I believe it's called Ruler.
Yes. So this is
How was that developed?
Yeah,
Um,
so this is a new type of reward function. I mean, new may be too strong of a term for it. I think it's a different application of an existing reward function. So like I was saying before, you need some kind of way to like tell your model, hey, this is a good output, this is a bad output. Push your weights further in the direction of replicating this output and away from replicating that output, right? And GRPO, it uses relative rewards, meaning that if I give you like if I create say two different trajectories or two different histories of model behavior, and and I put them in a group. If I give one trajectory a score of 0 and the other trajectory a score of 1, that is equivalent to me giving one trajectory a score of -1 and the other trajectory a score of 0. So it's like the scores are not absolutely meaningful. They're only meaningful with relation to one another, if that makes sense,
right.
within a GRPO training run. So what Ruler does is it takes like all of the trajectories that are going to go into a GRPO training group, and it assigns them scores relative to one another using an LLM judge. So you take the input task, like you give the training scenario that your model's learning at a given time. Um, you put that into the context of some LLM judge, which can be O3, O4 mini. Sometimes it can even be the base model that's being trained. Like if you're training a Qwen 332B model, you can actually like you can remove the LoRa and like ask the base Qwen 32B model, hey, like which of these outputs is the best and which relative score should be given to them from a scale of 0 to 1. So that's pretty cool. You can actually do it all on a single GPU. But in any case, whatever model you're using, you take all of the outputs of the model that you're training and you send them simultaneously to an LLM judge, and you ask it to give relative rewards, taking into consideration the task description, how well the model performed on each of these runs. And then you take these relative rewards and you give them to GRPO. And I think just to reiterate, like the reason this is very cool, especially in the context of GRPO, is that GRPO only cares about relative rewards. So you've
Mm,
calibrated the judge, right? on like the reward that it assigns each of these trajectories is relative to the other trajectories in the group, and the reward, like the degree to which the model's weights will be adjusted to each of these trajectories, is based on its reward relative to the group in the GRPO training algorithm. So this kind of LLM judge technique is just a really good fit for the reinforcement learning that we're doing with GRPO.
Does that mean it falls into the same advantages, disadvantages of GRPO, where you said GRPO is only when you have something to compare or the results need to compare to themselves?
Exactly.
Correct.
Yes. Yes. So this is we're using ruler to calculate the advantages and disadvantages of each trajectory.
Gotcha. And what has I know you talked about like the email campaign, but are there any other cool projects that you're able to spin out using this method?
There are some that I can't talk about that are like
Ooh.
real production use cases. I guess I can describe some in general terms. We've dedicated as part of the promotion of art. We've spent some time on these kind of like open notebooks that you can step through in a separate tutorial and all that. We've also been spending probably more of our time working with actual customers. Because like it's very easy to win on academic benchmarks or on like some simulated task that you design yourself, but we wanted to know if this worked. So we went to a few of our I guess more advanced customers who we had very strong relationships with, and we said, hey, you've got this task. Fine tuning has gotten you X far, but we think we can get further. Can we try it out? And so one of these is a voice agent that I can't tell you too much about it, but like basically it has to interface with a customer and it has some kind of verifiable reward at the end of whether it did a good job or a bad job. And we have decreased significantly the we've decreased significantly the number of times that the model like just gives up and asks for a human because we've shown it more examples of how to deal with problematic customers. um, and we've increased dramatically the percentage of times that the model takes the user's instructions and does the right thing for the task. And I really wish that I could give more details on both of those points. Um,
I can
but
picture it though.
uh, but yeah, no. So I guess the high level takeaway is that it's very good on difficult to verify tasks because like I said, there's some verifiable reward on this task, but there's a lot that's very difficult to judge. Like, did the model, take longer than it should have to understand the user's request? Was the model like respectful or was it disrespectful or did it ignore some part of the user's instructions? So there's a lot that Ruler can judge for us automatically without us having to create some kind of handcrafted reward function.
Making sure that's respectful and everything is all within the what was the word? The boundaries or the kind of the rail guards as you talk about, right? That's how you make sure it like stays polite.
Yes, that's
Guardrails,
definitely
guardrails here.
yeah, that's definitely something that you want your model to be in production, right? So I think one of the cool things about Ruler is that you don't need to create like a custom prompt specifically for Ruler in most cases. You can just like you can base on the system prompt that you provide your model in the first place. If you say something like be respectful in the system prompt, then Ruler will take that into account when assigning rewards to each of the trajectories. And like it will have a baseline of what respectable is. Like so if I like to give an example of why this is easier. If I like showed you a phone transcript between two people, say a customer service agent, a human one, and another human, and I asked you, was the customer service agent respectful? Like you might know right off the bat, right? Oh no, they were super disrespectful, or they might call the customer sir or madame or whatever and say like, oh, they're respectful. But there's probably a very large, like maybe 70% of calls. This is gray area where you say like, I don't like, what do you mean by respectful? Like, I guess they were respectful. They could have been more. But if I show you two calls, if I say, here's like representative A, here's representative B, which one was more respectful? Then it's probably going to be easier for you to say like, okay, like, customer B called or representative B called the customer sir one time. Representative A never called them sir. So I guess representative B was slightly more respectful, right? So, so this kind of like relative judgment is far easier than an independent judgment when calculating advantage.
Gotcha. And so we talk a lot about the advantages of this method and like how where fine tuning is kind of going in the future. But is there anything in particular that you would say that is difficult to fine tune, or it's just not worth doing at all? Like what should be fine tuned, what should we not?
Yeah, that's a great question. And honestly, that's something that we think about a lot at OpenPipe, right? In the early days, we didn't know how well reinforcement learning would work for anything, or even before that, supervised fine tuning. Like we had to run a lot of these experiments ourselves. I think so. These days, I guess first I'll start by giving a distinction between when you would use SFT, which is the other most common fine tuning technique, supervised fine
Mm,
tuning, versus when you would use reinforcement learning. So you would use SFT when you have a bunch of good behaviors of what you want your model to emulate. So, for instance, if you're training a classifier, that's actually a great example of a time to use SFT. If you've got um, uh, if you're looking for a very particular job candidate and you've got a whole bunch of data of job candidates who've been accepted and done a good job in the past, you can sort of like train your model, right, with examples of these job candidates being accepted and they should be accepted, and these other job candidates, given whatever resume as input, should not be accepted, and you can create this great data set that creates that like turns your LM into a classifier which determines whether you should and should not accept candidates. So that's an excellent opportunity to use SFT, supervised
mm,
fine tuning, when you've got like a correct behavior that you want your model to learn to emulate. We used to tell people they should also, or could at least, also use SFT to improve model behavior for like a variety of other tasks as well. These days, because reinforcement learning is available, I think it's generally a better fit. And so let's see, can I carve out any area where I don't think reinforcement learning is useful? Yes. There are kind of like two failure modes for an LM in production, right? One is that it knows how to do a task or like theoretically is capable of doing a task, but it's not reliable enough for some reason, right? So it sort of like maybe 9 out of 10 times it does the right thing, it takes the customer's orders properly, but 1 out of 10 times it like goes off the rails or it forgets a customer instruction. So that's like this is a failure mode of lack of reliability.
mm,
The other failure mode is lack of world knowledge. So if your model just
mm.
doesn't know information about the world, then it's going to perform poorly. So a great example of this, which was initially a disappointment to us, but now it's a learning experiment or experience. We tried to use reinforcement learning to improve small models' uh, ability to play the New York Time connections games. So I don't know if you're familiar with it, but basically you have a list of 16 words. You are trying to group them into groups of four based on some kind of connection, and the connection is usually not obvious to most people. Like you have
Mm.
to think about it, like maybe a submarine and a sandwich might be grouped together because like they're both subs, something like that, right?
Oh, I think I've heard of
Like
this
it's
game. Yeah.
exactly, it's not intuitive. You have to know a lot about the world. And it's hard for humans. Now, O3 does amazing at this. Like O3, I think we've sent it maybe 10 or 20 New York Times connections puzzles, and it just aces them. Like 88% of the time. It gets all the groups right the first time. Uh, and we thought, okay, this is probably something that we can train a smaller model to do. That would be super impressive. Right now, models like, I think at the time we were trying to train Quen 2.57b, it gets like a 10% win rate, but let's see if we can get that up to at least 50%, right? And we tried fine tuning, we tried reinforcement learning. I think the highest we ever got Quen 2.57b was like 20%.
Mm,
And the problem is that the model just doesn't know enough about the world. Like
mm,
legitimately, if you don't know that a single author wrote 4 books that all happen to have like these random words in them on the New York Times connections puzzle, then you can't win. There's no like connection in your database for you to be smart enough to think about. So you can't or at least we don't recommend using either supervised fine tuning or reinforcement learning to increase world knowledge. So to sort of
mm,
teach the model facts about the world, that doesn't usually work. Generally speaking, that should be done during the pre-training phase. So when one of these big companies like DeepSeek or Meta or OpenAI is training their models, there's this long phase during which it's just ingesting information about the world. That's the best time to teach the model new facts. but actually trying to teach the model facts after it's already been RL'd um, is going to be slow and expensive and really really difficult. So if you need a model with large amounts of world knowledge, you probably just need a larger model.
So when we talk about like Quinn and Llama and these different versions that they have, depending on how much knowledge that they have, are these, would you say that all the models have the same amount of information in relation? So it's like if Llama's smallest, I guess, data size and Quinn's smallest data size, do they have the same world knowledge, or is it more focused on like foreign information versus like Western information? Like what, would you classify it as that like the same data or no?
It's a great question, and I do wonder if any papers have been written on it. I actually don't know. I don't know if like the amount of knowledge imbued in a model's weights has been increasing. I think like if you wanted to run that experiment, what you could do is look at Llama 2.7b, for instance, and look at Qwen 2.57b and like see how much they both know about the world, about like events prior to, whenever Llama was released, so 2023.
Mhm.
Like I'd be very curious. I actually don't know. I have a general sense that over time we've gotten better at encoding more information into the same like numbers of these connections. In part just because the pre-training phase has gotten longer and longer, and more compute and more data has been used. But like in terms of actual density, I am not sure. I'd be very curious to learn that.
And is there such thing as like a live database then, or are they all just snapshots? So like, um, I know Grok is probably the one that's most up to date, and like if you ask it, it'll tell you about like recent user events. But I'm not sure with like ChatGPT or Claude if it always has like real time data. Like, is there such thing as having real time data and you can immediately just feed it through the GPT, or does it have to have a snapshot that's updated like every month or every week?
Yeah, so it's actually a mixture of both. So Grok, for instance, what it's doing under behind the scenes is sometimes querying its own weights for information, and sometimes querying the web for information. And the same thing is true if you're talking to ChatGPT, if you're talking to Claude's model, they will do web searches, and they will and they'll use the information that they find to answer your question. So the actual weights of the models themselves, that's a snapshot. The information contained in the weights of those models is not going to change as long as you keep the same weights. But like in a deployed setting, you can definitely deploy your model in such a way, and this is the way that all the big labs do it in their chat interfaces, that it can query the internet for information.
Gotcha. And it's basically doing a Google search on its own, I'm assuming, right? That's all
Exactly.
it is. Gotcha. Okay. And so with what OpenPipe is doing and making it readily available for a lot of people to kind of use cheaper and smaller models to better do the tasks that they wanted to,
Yep.
it, after reading like your blog and how you set up like these reward systems and learning about um, the bitter lesson being like how helping people find, or I think it went somewhere along the lines of like AIs will take advantage of the fact that they have more computing power than humans, right? And so what'll end up happening is it'll come up with solutions to problems that aren't as elegant to us humans because we think of things in a certain way. But AI and computers will just use that raw computing power to find the best way to do something that we can't do.
Right.
So I guess what I'm trying to ask is with the next 10 years coming and everyone talking about, AGI and I feel like the basic assumption here is that like legacy models would just be able to do what all these smaller fine-tuned models will do. Is that a threat to you guys? How do you see that kind of scenario playing out? And will there always be a market or will there always be a use case for these smaller fine-tuned models?
Yeah, it's a great question. So post super intelligence, we don't have any plans. We're gonna we're gonna see what the super intelligent AI wants to do, and that's probably the way the world's gonna go. Hopefully we've done a really good job with the alignment problem. I think pre-super intelligence, there um I think there are some basic constraints that will drive developers toward these smaller models, probably forever. at least as long as electricity and GPUs are somewhat scarce. So like at a high level, right? If you've got a model with an enormous number of weights, and you have to run those weights every time you compute a new token, it's going to be expensive and it's going to be somewhat slow. If you've got a very small model with like a limited number of weights that's very specialized on your particular task, it's going to be a lot faster and it's going to be a lot cheaper. So I think for reasons of quality and speed, probably forever, even as these large closed models get better at your task, which could, maybe if they're terrible at your task today, they might be better in a year or 2 years. Um, it still will probably make sense for you to have smaller models that can do your task well, and potentially, probably, still better than the closed models. As these closed models are getting better, so are the open source models. Like Qwen 2.5 was a huge leap over I think previously maybe Mistral 7B was like the best small model that you could use, and maybe Llama 3.1, but honestly, Llama 3.1 was a bit of a disappointment. And recently we've seen Kimi 2, right? So that model is performing it. It's a non-reasoner, and it's still performing at many tasks better than O1 did. And you can fine tune that. It's expensive and it's slow, but you can fine tune it and get even better performance. I think like so aside from quality and speed, the reason that I'm not too concerned about like kind of the open source side dying sometime in the future is that that's not really what we saw um, in the last huge wave of innovation, right? In the web. Uh, we don't run our servers on Windows, even though the first, at one point, the most common server for an enterprise to use was Windows. We all moved toward open standards, even though they were initially less performant, because we just like to have that control, right? No
Mm,
business wants to get sucked into OpenAI's whirlpool or Anthropic's whirlpool. No business wants to be beholden to some other company not cutting them off. Um, like we saw with with Windsurf, and uh, and I think we're going to see that with a lot of startups who maybe just got killed or are extremely threatened by OpenAI's moves yesterday. So I think the amount of competition between these big labs and their previous customers is probably going to keep increasing. And I think the motivation to have your own model and chart your own destiny as opposed to being beholden to a closed source provider is probably only going to increase in the future relative to where it is today.
do you think the norm is to actually go through like reinforced learning, or do you think it's like because right now I feel like the norm is to create workflows in apps like Zapier and like N8N, if you've heard of that, where
Mhm.
you're able to seamlessly plug in these models and kind of prompt it properly to take this input, put it out here, uh, make this and put into a spreadsheet and use these ideas to generate this through this app, you know? Like that seems to be the most intuitive way that people are able to kind of achieve something like you've talked about with like an email agent or having I don't know if it could play 2048, but yeah, I guess what I'm trying to say is, do you see this as being the norm as like NAN becomes or has some limitations, or do you think it'll take that form with reinforced training, just making that better?
Yeah, that's a great question. So, um, I think it's not really a trade-off between N8N and these other platforms on which you're building AI agents and reinforcement learning. I think like at the end of the day, you're using some model on this platform, right? Maybe it's a closed model like one of Anthropic's. Maybe it's an open untrained model hosted on Cerebras or something like, Llama 3.170B. Um, I think that like the question of which model you're using is like that's up to you. You can use whatever workflow you're building. If you're building it through Zapier, if you're writing your own custom code, whatever, the actual model that you're using to perform the LM tasks is up to you. And it could be a closed model or it could be something that you've trained with reinforcement learning. And I think honestly, for these platforms, what I would do in their shoes is probably come up with some kind of reinforcement learning integration because it is so powerful. And if your user's already on your platform and already performing LLM workflows, then like just adding reinforcement learning on top makes a ton of sense because you've already got the setup, right? You've already got the simulation. So it'd
It'll
be
just produce a better output at the very end.
yes, yeah, it'd be pretty straightforward for you to look at a bunch of real user scenarios from the past, run them through your pipeline a number of times, and calculate advantage to improve the model's behavior for the future.
Interesting. I wonder if people are going to be able to solve the virality. So like for social media, right? Everyone's trying to understand what virality and what goes viral, what doesn't.
Yeah.
And a lot of people are trying to generate AI content that will go viral.
Yeah.
And so we have all these like NA and agents. But with a fine-tuned model, I wonder if you can really pinpoint and just consistently produce that. In theory, if you feed it
Yeah.
enough like viral clips.
Yeah, so our CEO Kyle actually did this for Hacker News because that's like the I guess he's the kind of guy where that's his social media platform is
Oh,
like
really?
yeah. But to be fair, like whenever I go on there and I go on pretty often myself, like there's higher signal, there's higher quality content there than almost anywhere else I can think of. But he did this for Hacker News posts. So he like analyzed all the ones that got the most upvotes, the most comments, and he created a title generator, which like I think there's a whole blog post on it that we can link if people want to read that. But it did seem to work. Like the titles that it created were provocative. They made me want to click on the article and like read it. So I think there will be some of this. Um, I think there's going to be like there will be algorithms that people come up with to cheat other companies' algorithms. It'll be kind of like a war of algorithms.
All day reminds me of the whole debate on dead internet theory and how everything we're going to see online is just going to be generated.
Yeah, yeah. I mean, we're already moving in that direction, right? Even like yeah, we've worked with a number of companies moving in that direction, and I think it's for better or for worse. I think there's only going to be more of it in the future.
I wonder if it's going to evolve though, because like maybe we're not the ones that really reading or consuming content anymore. We have like a show or a butler or like a chauffeur. Would that be the right word? Or like a GPT that just recommends content for us. And so
Yeah, yeah.
now the content will be
A
having to
curator.
gain, yeah, you have to gain the LLM suggester or the recommender itself.
We're already like we're sort of in that world now to a small extent because people are now discovering OpenPipe, for instance. I can speak to our experience
Right.
through ChatGPT. ChatGPT will
Oh,
tell them
no way.
like this is the company that you use if you want to fine tune a model, and it's actually funny because sometimes people will come to us and they'll like tell us about features that we don't have and like how ChatGPT told them that we were like the best company. Look, ChatGPT, we're flattered. But we don't actually, I can't remember what the most recent one was. I think it was like we have a robotic simulation or something that they can use to train their robots. And like we don't have that yet. We'll work with you if you do have one, but that's not built into our product. So I think we're moving toward that direction of like you have to write your docs and you have to make your web page in such a way that an LM can easily navigate it. In fact, if you go to the OpenPipe docs, you can go to docs.openpipe.ai/llms.txt, and that'll show you what the LM sees when it tries to navigate the site.
Oh, look at that.
Yeah, so this is all written purely for LMs who want to read our docs.
I love how open you guys are about everything, just like from the models to the research to like how your website literally makes it so that people can understand everything.
Yeah, well, I think that a lot of that came from YC. Like YC companies just want to help each other. So you get in the mood, you get in the habit, I suppose, of exposing information to others and expecting them to do the same.
Mm,
So that's been good for us in the past, and we like paying it forward.
love that. Well, I know we're going over time here. I have one more, or I have a closing tradition for a question.
Yeah, let's do the closing tradition.
Awesome. So the closing tradition for this podcast, as you know, is a lot of people that are interested in Gen AI and people who might be building in this space. So as someone who's been through YC and who has seen a lot of success to my eyes, I guess, uh, what would you recommend builders that are building in this AI relevant world today to do in order to succeed?
Hmm. I would say build something that you're really interested in that seems useful to you. Like even if it seems very difficult, if it seems over ambitious, there are tools out there today that didn't exist a couple years ago, even 6 months ago, that will make your life way easier. So if you're not technical or if you're only semi-technical and you want to build something really spectacular, I would say just do it. Like it's going to be hard. You're probably going to run into issues that you didn't expect. But download Claude Code and and ask it for help and see what you can make. And I think that probably what you build will change along the way as you get feedback from your customers. Uh, but but I think that if you're ambitious and you're willing to work hard and you're willing to adopt these new tools, you can get a lot more done than you might expect yourself to be capable of. So just go out and do it.
Is someone who's not technical right now catch up with everyone?
I think if you're willing to work hard and you're willing to learn, yes. I think that it is easier to catch up with everyone today than it ever has been, like in the history of maybe of humanity. Because we have a database. We have these huge databases of almost all the knowledge that's ever been put on the internet in an extremely queryable format. So like, yes, catch up, ask questions. Do not be afraid to ask questions. Also, do not take everything that LMs tell you like completely seriously. You probably want to double check with your friends, for instance, before asking if like write to the database is going to lock it for production for 10 minutes. That's a random example, completely pulled from my imagination. Never happened in production, but like yes, you can learn very quickly. You can catch up. If you're excited about building something, just build it.
Awesome. Well, David, thank you so much for your time today. I think you made reinforced learning, the topic itself, very palatable and easy for a lot of people to understand. The way you talk about the subject and the passion behind it, I'm just really excited for where this space goes and like what people are able to do with it. So thank you so much for your time.
Yep, good talking to you, Magnus.